And basically, just so you have a list of the names of these polygons, because in math we use some highfalutin words there, some examples of them. Jot this down so you have it in your notes. Most of them are pretty simple. Most of them you've heard before. Sometimes you get confused as to which things are which, but let's just talk about them. A three-sided polygon, everybody knows, is that triangle. I'm sure that was one of the first things you learned as a young little child. And here I just have a place where you can draw an example. You know, they can look like this, they can be like this, whatever. Three sides. Oh, by the way, polygon, poly means many sides. So we're looking at many-sided shapes here. A four-sided shape, and this is the one where people get confused. Anytime I say four sides, they say, well, that's a rectangle or that's a square. No, in math, we call four-sided shapes quadrilaterals. Quadrilaterals. And they can be anything with four sides. A rectangle is a four-sided shape. A square, notice how I'm picking my pencil up every time I draw a corner. But a quadrilateral could look like something goofy that doesn't even really have any sort of a name. I guess you could call that a kite or something close. But any four-sided shape is a quadrilateral. A five-sided shape, anybody?
A pentagon?
Yes, it is a pentagon. And the generic form of a pentagon kind of looks like this. It's a house kind of shape. But anything with five sides is a pentagon. 1, 2, 3, 4, 5. A six-sided shape? Yep, hexagon. Very good. Hexagon. And the one we always think about kind of looks like this. 1, 2, 3, 4, 5, 6. But it can be any shape that has six sides. 1, 2, 3, 4, 5, 6. The letter L, if you did it in block letters, would be a hexagon. 7 sides, one we don't hear about very often. It is a heptagon. You looking at the book?
Yeah.
Hept. 7 sides. 1, 2, 3, 4, 5, 6, 7.
Heptagon.
8-sided shape is an octagon. And a lot of times we use the stop sign for that. 1, 2, 3, 4, 5, 6, 7, 8. But anything with 8 sides. 10 sides. Decagon. Like a decade has 10 years, so a decagon has 10 sides. I'm just going to do a goofy one here. 1, 2, 3, 4, 5, 6, 7, 8. What am I going to do here? 9, 10. And a 12-sided shape is a dodecagon. Ever popular dodecagon. And they use one in the book that's probably a good one. It's like the plus sign in block letters. That is a dodecagon. Oh, I suppose we have to define this too. In order for something to be a polygon, let's jot this down. We got a space to write on the notes there.
Oh no!
On the sides somewhere. Do we have sides on the space?
No.
Yeah, on the top up there. A polygon, for something to be a polygon, it has to have 2 things true about it. Number 1, it has to be made of straight lines, no curves. Straight lines. And number 2, a polygon has to be what we call closed. And I'll talk about that just shortly here. Let me write that down. It has to be straight lines and closed, which means it can't have any curves. What closed means is this. If you're drawing a straight line shape, and it looks like this, the way the book makes you think about it is this. Pretend that there are some ants inside that shape. And if those ants can find their way out, if there's a way for them to get out, like this, then it is not closed. A polygon has to be closed, which means those ants have to be trapped inside the shape. So this side would have to go here to there.
Because ants actually don't like
And then the ants can't get out, so it's closed. And they can't climb over, even though ants can climb all sorts of things. In addition to that, if you ever hear the book talk about a vertex is the corner of a shape. It is the place where two segments come together and touch. It's a corner. Katerina?
The way that I learned how to know that if it's closed is that what they did is they filled it in, and if it like on the board they would fill the shape in, and if there was a little bit that was
Spill out?
open, it would cover the entire page.
Sure. That works for me. If it's Now we do need to take a couple more pieces of note paper. You're going to need a couple more blank pieces of paper. In addition to this note paper, the first one is this. Right on top of the page, congruent. Well, you're going to need to. This one will be on one. The word congruent on one, when we talk about congruent with polygons, means that they have the exact same size and shape, which means this. If I have this, for two shapes to be congruent, my other shape would be exactly like it. Okay, same size and shape. Two things are congruent. It means they're equal. They are the same. I probably could do another shape like a triangle. Let's do a triangle. Oops, not that one. Let's go back. Copy and paste that. Okay, notice how those are the same size and shape. It could be turned. You know, I could have it like this. They're still congruent if they're rotated. Those are still the same shape. Now, with that being said, the other blank piece of paper kind of goes along with this, but we need to use two different ones because it doesn't start with the same letter. The other one we have to know is the word similar. And similar means same shape, not necessarily the same size. But you have to be a little careful with that. When we talk about something being the same shape, it has to be what we call proportional. And I'll talk about that for just a second here. Okay, it has to be proportional, which means this. Okay, there is a triangle. Okay, for another triangle to be similar to it, okay, these two triangles are not similar, even though they're both triangles. When you talk about proportional, what you have to think about is you think about it being a balloon. Okay, when you blow up a balloon, what happens? All the sides increase together. For this triangle to be similar to another triangle, it would have to look like the same squatty kind of shape there. If this side grows twice as big, then this side should grow twice as big. They grow equally. And that first triangle I had was shorter and squattier. This one's long and narrow. This one's kind of long and narrow. It is similar. Or a rectangle. If you were doing a rectangle, for another rectangle to be similar to it, okay, it would have to grow, both sides would have to grow together. Those two are probably similar. This would not be similar to it because it didn't grow equally at the same size there. Now, some things that are always similar, all squares would be similar. Because there's no way they would not grow at the same rate because all their sides are equal. In addition to that, guess what else is always similar? Somebody say it out there? Circles. Circles are always similar too. There's no way that you can grow a circle that doesn't make another circle that's just like it. And that's why balloons. That's why balloons. So when they ask you if something's similar, you have to be able to look at it and go, well, that one's not similar because, you know, it's squattier or shorter or whatever. Perfect? Good? Yes, I think that you will probably... Yep, lesson number 32.